In this video, we are going to go over the following type of monitor point for MSC Natsran. It's called the MONDSP1 entry. So this is what you can expect in this video. This is the entry we'll ultimately write out. And here's a quick agenda. I'll walk you through how to create one of these monitor points. I'll talk about how to interpret the results. I'll talk about how to export the results of the monitor point to a CSV file, and then I'll talk about how to quickly create hundreds or thousands of monitor points. Now, all of this information is from the following three documents: the quick reference guide, the linear statics user's guide, and the aeroelastic analysis user's guide. And then here I need to update this. So the correct name is the linear static analysis user's guide. Okay, so let's exit out of here and let's go ahead and talk about what the model is for today. Now, everything you see here is being done in a web application. So just in case you want to follow along with today's tutorial, you can get a free version of this web application by going to theengineeringlab.com. Here at the top right hand corner is a blue button for a free trial of this web application. Okay, so let's go ahead and now talk about today's model. So we have two beams. One beam here on the left is created with beam elements. Here, this other beam is created with 2D elements. So one side is fully fixed, and then the other side is free. And on the free end, we apply a point load like you see on the screen. Okay, we've gone ahead and perform a statics analysis on this loading scenario, and here are the deformations. Now, there's one problem when we look at the deformations. So here, let me go ahead and plot the maximum deformations. For this beam, it's really easy to know what the maximum displacement is for the beam. Here we see the maximum deflection is reported along the beam elements, which represent the shear axes of the beam. So here we know we have a deflection of about 0.00129 meters. But when we look at the other beam, we're looking at the deflection at the free end, but we have deflections reported at different nodes. Ideally, we would go ahead and report the deflection at the shear center for this beam. So in this video, we are going to define a MONDSP1 at the free end at the shear center. So we're going to report the deflection using a monitor point rather. Okay, so let's go ahead and exit here. Let's create a monitor point at this point that measures the deflection, if you will, for the other nodes here. So to do this, let's go ahead and see. We need to build first a set one entry. So let's go ahead and look for set one. And then we'll call this set one set 6. And let me move this, and here I'm going to select the nodes on the free end of this beam. So let's go ahead and do that now. And let's go ahead and resize this. So select these nodes here, and then these nodes. And then we'll rotate the model just to confirm we've selected the nodes that we want. And then I also want to create another monitor point here just to make sure that we have similar deflections. So let's go ahead and create another set. And for this one, I think I'll call it 106. And then for this set one, I'll select this node here. Okay, so we have our set ones defined. So again, set 6 has these nodes at the tip of this beam, and then set 106 has this node at the tip of these beam elements. Okay, now we have to create what's called an AE comp. So let's go ahead and create an AE comp. So just reset the table. And let's go ahead and build our AE comp here. So we'll build AE comp. And keep in mind that these AE comps do not use integers for the ID, they use labels or names. So here we'll say this is a comp A6, and then we'll create another a comp 116 AE or A106. We'll say these are going to source data from set 1. So we'll say this first one is using set 6, and this next row is using set 106. Okay, then we can go ahead and go to our MONDSP entry, and we'll create 2 new entries, which are at the bottom of the table. Here we'll call this a P106, and we'll call this a P16. And then here, let's give this a label. So this point is going to represent beam 2. So I'm calling this one beam 1, and then this one beam 2. So we'll go ahead and call this beam 2 deflection at the tip, and then this next monitor point, this is beam 1 deflection at the tip. And then we'll say these are going to store, right, these are going to store data for up to 6 components. And now here for the AE, or for this column component or the source, this the data for this monitor point is going to come from AE comp A6. And then the data for this next monitor point is going to come from AE comp A106. So A6 and A106, that's the data, the displacements from these nodes at the tip, and this displacement at this node. So let's see, what else should I, okay, so now we have to specify where are these monitor points located. So I already took time before this exercise to identify where these monitor points are situated. So this point here, which is going to represent the tip at the shear center of this beam. This is located at x equals 5 and z equals -2. Now, when you supply this data, the model display panel will now have a new row for that monitor point. So here we have P106. Let's go ahead and turn on this first checkbox. So this is the position and the orientation of this monitor point. It's not visible here, or it's a little hard, but the y-axis is this green axis that goes up and down here. Now, if you want, you can turn on this checkbox, and this will tell you which nodes are contributing data to that monitor point. So the square boxes, these are going to represent the nodes that are contributing the data. And then this larger square here, this is the center or the position of the monitor point. And then if you want, you can also display a label with this next checkbox. So here, this is the monitor point that we've just created. Okay, now let's go back and define one last thing for this monitor point. So now we have to specify what data from these nodes is going to supply data to the monitor point. So here on this far right-hand column, we can say, just consider deflections from those nodes that are going in the second degree of freedom. But here we'll say consider all 6 degrees of freedom for the nodes. Take the deflections and the rotations for all 6 degrees of freedom for those nodes and feed them to the 6 components of the monitor point. Okay, now let's go ahead and now focus on the monitor point for the beam elements. So here, these beams are going to end up at x equals 5, y equals 0, and then z equals 0. And here we'll only consider we'll consider all deflections and translation and rotation. Okay, now if you exit here, we can also turn on the monitor point for the tip of the beam. So here you can see we have another monitor point. We'll turn on the label, and then we'll turn on the markers, if you will. So here, you don't see it, but there is a second marker. There are 2 markers. One marker represents the node that it's providing data, and then the second larger marker is the marker representing the monitor point, but since they are both overlapping, it looks like there's only one. Here, it's more clear here. Here, the larger square that represents the monitor point, and then the smaller squares represent the sourcing nodes, if you will. Okay, now one other thing. So we've created our monitor points. Now, if you want to output the data for those monitor points, you have to turn on the monitor command. So here we jumped over to the case control section. Here, I've turned on the monitor command, which is listed here on the right. And then under monitor, here we're saying output all the data for all the monitor points. Okay, here you have some options to control what's output, but I'm going to leave those untouched for now. Okay, let's go ahead and run this. Now, let's go ahead and see if I still have the data. I do. Okay, so keep in mind that our maximum deflection at the tip of the beam is 1.29 times 10 to the negative 3, or here, let me go ahead and type this down in another text editor, 0.00129. So here I've just reported and documented what the tip deflection is. We're going to come back to this in a moment. And this is negative, by the way. Right now we're looking at the magnitude of deflection. So here, let me just go ahead and select the y component of deflection. So now we see that's negative 1.29 times 10 to the negative 3. So all these values are agreeing. Now let's go ahead and rerun this, and we'll go ahead and look at the results for the monitor points. Now the monitor points we want to look at are the ones we created. P6, I believe, and P106. I actually forgot what the names of the monitor points are. Okay, so we want to look at P106 and P1116. Okay, so we'll do this. Okay, now how do we look at the results of the monitor points? So you will look in the F06 file. So here we'll look for, here in the bottom left is a search console for Mozilla Firefox. We'll type in P106. And so here we have the output in the F06 file for those two monitor points. So let's go ahead and copy this data. If you want, you can download the F06 file, and then you can go ahead and look at this in a text editor. Here, that's what I've done. I've downloaded that F06 file. So let's go ahead and look for that P106. So P106. And let's move this to the side. So remember that the y component has a deflection of a negative 1.29 times 10 to the negative 3. And if we look at the first monitor point, so here, if we look at the label, this is the deflection for beam 2 at the tip. And then for the next monitor point, if you look at the label, this is the deflection of the tip for beam 1. Here, we're only focused on the deflection for component 2, or CY. Here we see the component is negative 1.3, which aligns with the expected deflection. And here for the next monitor point for the beam with the beam elements, we have a very similar deflection, negative 1.29 times 10 to negative 3. Okay, now let's suppose we do not want to consider CY in this calculation. So how will we do that? We go back to the monitor point, and we deselect component 2. Let me make sure, right, so let me go ahead and modify the last two monitor points. So the last two monitor points are the points we created in this exercise. I've deselected component 2 for both of those, and let's go ahead and rerun this. Oh, I got a user fatal message. Oh, right. So here, let's see if this works. I'm getting some messages about not providing enough degrees of freedom here. So let me go and see if this works here. I don't expect this to work, but we'll see if we get lucky here. Right, so I guess I still need to provide all degrees of freedom here. So we'll skip that part. So we'll re-enable these. Okay, so now let me rerun this. Okay, so what's next on the agenda? Let me go back and fix all of these. So here, I need to select all of these. Okay, so we looked at the data in the F06 file. There are other ways to look at the data, and right now I'll take time to show you how to look at the data in a different way. So here we're looking at the deformations. Let's go ahead and select this data set, MONDSP1, and let's go ahead and select the first checkbox. And now let's go ahead and look at the value for the second component. And let's mark the arrow plot. So this is going to show me the value of that monitor point for the y-axis, if you will. Here, the monitor point is telling us that the deflection is negative 1.29 times 10 to negative 3. And then here, similarly, we get a deflection of negative 1.3. Okay, now I've taken time before this to define additional monitor points. So let me show you what those look like. So here, I've gone ahead and created monitor points tracking the deformation at various points along the shear center of this beam. So now what I can do is this. Let me hide the beam element or the 2D elements, and now let's go into post. And now if you look here, we get the vertical deflection reported at each monitor point. So that's one way to, another way to look at the results. Now, I know a lot of you are now asking, okay, I need to output this data to the CSV file. Now, I tell my developers this. I tell all my developers, never try as hard as possible to never read the F06 file. This is a very painful process to read the F06 file. It's very rare that you will have an easy task. So this is what I recommend. Open the file, open the H5 file. Open the H5 file. So here, I'll give you an example. Let's open the H5 file in the HDFI Explorer. Here, we have monitor point P106 and monitor point P116, the same monitor points we created in this example. Here, what we can do are two things. Number one, we can create a plot. So we'll click on create plot. Here, we'll switch to looking at a bar chart, and we'll look at the Y component here. Right, so here we have our P101. Right, so this is effectively 0. And then here you see what the deflection is for these. So you can create a plot of the data here, or you can export the data to a CSV file. So here, if you look at this table contains the plotted values. In the top right hand corner, you can export the data, or in this original table, this table has all the values for all the components in the monitor points. You can click on download CSV, and now in your downloads directory, all the data from the monitor point is now in the CSV file. So if you wanted to, let's see if this will work. Let me try and create a bar chart here. I don't know if this will work, but we'll see if it works. Okay, and then let's go ahead and do this for, yeah, I thought that was going to be, okay, let me do this. Let me just delete the first 3 columns. I know some of you might be a lot better at Excel than I am, so I expect this. Okay, so here right now what we're plotting are the deflections for these monitor points here. That's where we're plotting. So if you remember, let's go ahead and turn on the labels maybe. MONDSP1. So here are the labels for the monitor points. So here at the root, the fixed stand, we have monitor point 101, 102, 103, 104, 105, 106. So we're reporting the deflections along the shear center. Here, we're looking at only the Y deflections. So here are the Y deflections along the shear center. Now, quick comment about this deflection. Actually, something looks kind of off about this one. I should be getting a 0 value, but I'm actually getting a non-zero value. So this could be, let's look at this. Let's go ahead and look at set, or what am I doing? Let's go back here and let's turn on this checkbox. Oh, okay. So for this first monitor point, I'm using the wrong nodes, so we'll have to fix that in a moment. Right, so for this monitor point, we're using these nodes. For the next monitor point, I expect to use the local nodes, right? So these monitor points are incorrect. So let's go ahead and fix that. So P106, we'll go ahead and go here, A2. Okay, so set 2 is what we have to modify. So set 1, set 2. So these are wrong. So expect these nodes to be highlighted at the, first let's turn on our beam elements here. Oh, no, it was this set of beams. So you see these these nodes are being selected. These are wrong. So let's go ahead and delete those nodes, and then let's go ahead and select these nodes on the far left-hand corner. And let's go ahead and rotate this. Okay, let's close all of this, and let's go ahead and look at our updated monitor point. So before, this monitor point was sourcing data from the nodes at the tip, which is not what we wanted. We want this monitor point to determine the deflection based on these nodes in the general, or the cut, if you will. Okay, once we made that correction, let's rerun this. So let's go ahead and rerun this. And now let's go ahead and open the results in the HDF5 Explorer. So again, the goal is to output this data to CSV file, because I know many of you want to do some additional calculations with this data. So I'll show you how to do that. So we'll select the MONDSP, we'll download the data set, and now we'll create a plot like we did a moment ago. So let's go ahead and do this. We'll delete these, we'll select these values. Okay, that's a lot better. So there was an error on the first part of this video. So I was getting a non-zero deflection for the root, but since at the root we fixed the beam, we should be getting a 0 deflection, but here it was showing me a deflection of 0.0006. Here I found out that one of the monitor points was not defined properly, so I had to go and fix that. Once we fix that, at the root we now get a 0 value. And then here we see what the deflection is along the shear center for this beam 2. And then here at the very end, we get a deflection of negative 1.3 times 3. Let me say that again. Negative 1.0013. Okay, so now let me make a few additional comments. Let me delete all this data. There is a need to create many, or actually let me do one other thing. Suppose you want to report the values in a different orientation. This is how you would do that. So let me go back and modify one of these MONDSP1s. Let's go ahead and modify this field. I'll focus on the beam on the left, so beam 1. So right now, this is currently the orientation of the monitor point. So one thing I like to do when it comes to any coordinate systems, I like to use a stick figure. So here, there is an observer at the monitor point. This observer is going to observe the displacements, and this is the orientation of this observer. Now, suppose you want to use a different orientation. You would modify this field. This is the CD field. If you click on display descriptions and hover over the description, you'll get more information about what this does. But here, I'm going to say, you know what? I want to angle this observer, this monitor point. So I have this other coordinate system here. So let's go ahead and turn on the name of this coordinate system. So this is coordinate system CID1. You can see that it's angled. I'll say, you know what? I want the monitor point to have this same orientation. So what I do is I select this coordinate system. And then if we look back at the updated coordinate monitor point, you'll see the monitor point is now oriented a little differently. So this is what it looks like now. And then when you go ahead and run Natsran, and when you look at the results, they are going to be different. Actually, let me rerun it. Okay, let's go ahead and jump back and look at the F06 file. So we did this for P116. So let me go ahead and show you this. So P116 is this value. So when the monitor point had the previous orientation, we knew that the deflection was negative 0.0013, like you see here in this row 8. But then when we use the new orientation, notice that the deflection is different for the y component. It's negative 6.64 times 10 to the negative 4. That's because the orientation of the monitor point is different. The orientation of the observer is different. So this observer is going to view the deflections a little differently than before. Now, if you want to revert that, you can just do this. You can just delete the existing CID, which defaults to the basic coordinate system, which has CID 0, or you can just type in 0 and it'll do the same thing. And so here was the original orientation, which we used for most of this exercise. So I just wanted to make a comment on how to orient your monitor points. Okay, now a few moments ago I was saying that some of you might have a need to create hundreds or thousands of these monitor points. How will you do that with the web app? Here in the top left-hand corner, you can click on Download CSV file. So now we have a new table. Here, what I'm going to do is this. Let me renumber these. Let me just create maybe 50 for this exercise. Here, what you can do, you can program. You can use Excel to program your monitor points. So here I'm just copying and pasting. We'll go ahead and delete these last few rows. We'll save the CSV file and then we'll re-import the CSV file. So before we had 1, 2, 3, 4, 5, 6, and 7 monitor points. And then after the upload, we should have a lot more monitor points. So here, let's go ahead and display 50 rows per page. So now all the monitor points we defined in the Excel file or CSV file, they've been imported to the web app. So now you could go through the process. You would run Natsran. You will look at the deformation or the values in the web app. So here we could look at the values of the monitor points. We could open the results in the HDF5 Explorer, and then we can output all the data for the monitor points to the CSV file. And then we can go ahead and do additional calculations on all these values for the monitor points. Okay, now I think we're towards the end of this video. Let me go ahead and see if we did everything. So we created a few monitor points. We interpreted the results. We output the results to the CSV file. We created about 50 additional monitor points. You could use the same procedure to create 100 or hundreds or thousands of monitor points. And now one last reminder before we stop today. All of this was done in a web browser, as you saw here. If you want to follow along with today's exercise, you can visit theengineeringlab.com, and then here in the top right hand corner is a blue button for a free trial. Fill out the form and we'll go ahead and give you access to today's demonstration. Okay, so there you have it. That's how we work with a MONDSP1 entry, one of the many monitor points available in MSC Natsran. And as always, thank you for watching.